Welcome back. Let's now talk about section 2.8 absolute value inequalities this time. And we have a few things that we need to say about inequalities in order to help us solve it. And in fact, there are two separate rules that we have to do. We'll just talk about the first one. The rule states that if we have the absolute value of some quantity less than C, what should we do with it? Well, let's make a couple of specifications. First of all, we have to make sure that in this inequality setup, we must let C be a number that is greater than 0. I'm going to leave this as an open-ended question for you to answer yourself. Why? Why do you think that is? Good one to think about. But for our purposes, all right, we're going to specify. Let C be greater than 0. Then what do we do with this quantity? Absolute value of AX plus B is less than C. Well, if this is the case, then our rule states we should restate our inequality as a compound inequality. So we want to involve negative C here and say that the quantity AX plus B must be between negative C and positive C. And you think to yourself, well, how could that possibly be? Let's make a number line right here and just illustrate the point with a really simple one. Right? Let's say I've got 0 right here. Here's 1. Here's 2. Here's 3. And I've got absolute values here. Sorry, here's negative 3 on my number line. And I tell you the absolute value of x is less than or equal to 3. And it's a very simple version of this, but what is this telling us? This says the distance of x from 0 is less than or equal to 3. Well, certainly any number between 0 and 3 would fit this description, right? Because I could put in 1, and the absolute value of 1 is less than 3. I could put in 2.5. The absolute value of 2.5 is less than 3. I could put in 0.39, and 0.39 would be less than or equal to 3. But what about other numbers out here, out to negative 3? Well, it must be, because the distance from x to whatever number we're interested in must be less than or equal to 3. So what about the distances back here? What if I were to put in negative 2.5? Well, that's certainly true, right? So in fact, this is equivalent on our number line to saying all these numbers between negative 3 and positive 3 have an absolute value less than 3. And if we were to put this in here, then we could say that, well, x is less than or equal to negative 3, and x is less than or equal to positive 3. So it must be a compound inequality of this form in order to solve this. All right, let's put this to the test. Let's try a couple of examples. Let's say I've got the absolute value of x minus 3 is less than or equal to 5. Well, by this rule above, we restate. Eliminate the absolute value brackets by rewriting our inequality as a double inequality. So we rewrite. I'm very careful here to write my word rewrite. Absolute value of x minus 3 is the same thing as saying x minus 3 is less than or equal to positive 5, but greater than or equal to negative 5. So in other words, the quantity x minus 3 must be between negative and positive 5 in this setup. Well, now the solution is actually quite easy. We're going to just add 3 to each side of our inequality. Add 3, add 3, add 3. X will be between 8 and negative 2. All right, so if we're going to write this solution in set builder notation, well, that's actually pretty easy. We already have part of it written for us, but our solution, if we say set builder notation, means to rewrite it so that in the brackets, we say we want the set of all x such that x is between negative 2 and positive 8, including 2 and 8. So we'll write it this way for our solution, since that's what we're asked to do. All right, let's do the same thing with our next one right here. The absolute value of 3x plus 2 is less than 8. Again, we rewrite. We're going to put negative 8, 3x plus 2, positive 8. Okay, so let's subtract 2 from each part of our inequality. Subtract 2 from the left, subtract 2 from the middle, subtract 2 from the right. And we carry out our work. We got negative 10 over here, which will be less than 3x, will be less than positive 6. Now we divide everything by 3. Divide by 3. Divide by 3. We're going to get negative 10 thirds as a fraction on the left. We're going to get x now being isolated after dividing by 3. Positive 2 on the right. So just as we did before, if we want to write our answer in set builder notation, here's what we do. We take the set of all values of x such that x is between negative 10 thirds and 2, but not including the endpoints in this case. So that's our answer. More examples in the next video.